Bismillahirrahmanirrahim. Dear friends, in the previous videos, we have learned how to model, analyze and design simple elements like beam and two-dimensional frame. In this exercise, we will see how to model a single-story house of a given plan. The problem statement is, model a single-story house using the following data. Story height is 12 feet, foundation depth from plinth level is 5 feet, beam size is 8 inches by 24 inches, column size is 12 inches by 15 inches, interior and exterior masonry wall thickness is 6 inches. The material properties are compressive strength of concrete for columns is 4000 psi and for beams is 3000 psi. Yield strength of reinforcement steel is 60,000 psi. So let's get into the software screen. This is the plan that we are going to model in MIDAS GEN software. So just open MIDAS GEN. Now open these two windows side by side so that we can work easily. Okay, now we can see that our unit system is in FPS. So just go to select the force unit as pound and distance unit as feet. Now go to the structure tab. First we will create the line grids. So define the line grids, add and name it as grid 1. For X lines, just take it as 10 feet first, and then there is 2 times of 4 feet 8 inches. So 4 feet 8 inches, 8 divided by 12 is 0.667. So 2 at the rate 4.667, 2 times of 4 feet 8 inches, right? Comma 10 feet. That's it for the X lines. So for the Y grid lines, just add. We want to have the origin at this particular point. So we are starting from the bottom. So 12 feet, comma 6.5 foot, comma 10 foot 1 inches, take it as 10 foot, and 10 foot 11 inches is taken as 11 foot. Okay, apply. Alright, so this is our grid. Just go to this top view button, and that's it. Now what we want the columns at the intersection of these grids. So to create the columns, first we have to create the nodes. So just go to the nodes and element tab and create nodes and click where you want to have the column one by one. So I am just creating these points, these nodes. So that's it. We have created the nodes. Now turn off the grid lines from this button, line grids, and click on this button to view the isometric view. Now we will model the columns. So to do so, just go to extrude command. We want the columns from the plinth beam to the foundation as 5 feet. So just input dz is equals to minus 5 foot. Select all the nodes and then apply. This is already set as node 2 line elements. Alright, so the columns have been created. Now we will create our beams. Just go to the create element tab. Up till now we don't define any material properties or section properties, just we will create some dummy lines, dummy beams and dummy columns. So just draw the beams. For horizontal I will move from left to right, and from vertical I will move top to bottom. Alright, so these are all our beam and column. I have mistakenly draw this column, so just select it and delete these nodes as well and create line again, right? So this is okay. So this is the main beams and columns that we have modeled. We will model some other plinth beams as well to carry the loads of the walls. So to do so, just go to the nodes and element tab, create element, and from this particular column to that particular beam, and then that beam to that beam. So I will select this ortho button so that the beam that is created is from this point, it is resting on the other beam at 90 degrees. So click here, similarly from here to here, and from here to here as well. And there is this masonry as well. So to do so, just measure this distance. Measure this distance from this column to, let's say, this point is 2 feet 7 inches. So 7 divided by 12 is 0.583. So go to the translate tab and select these two nodes and translate it in the negative y direction, 2 feet 7 inches. So 2.5833, minus 2.5833, and click on OK, apply. So this is the nodes that we have created. Join them by a line, create element, and ortho on. Make sure that when drawing the lines, this particular option, this option intersect node and element is checked here, so that any particular beam is in the way of this beam, the software will automatically create a node, otherwise it will not be created the joint between these two beams. Okay, so this is the beam, and there is another beam that we want for the masonry is 6 foot 6 inches. So just go to translate button, and we want to translate this beam this particular beam in the positive x direction by 6.5 feet. So automatically sometimes take any values, so just disregard this thing, 6.5, 0, and yes, check this intersect and element option as well. Apply. For this particular beam, it is with the minus sign. Let's uncheck this option. Now try. Now what the software will do is create this particular beam, create these two nodes, but this beam is not being divided by this node, so that the connection between this beam and this beam is no more until we select this option. So just Ctrl Z, intersect nodes and element, this, and apply. Now this beam is being divided by this particular node. Alright, so in this way we have modeled almost all the beams. So now we will copy these beams for the roof. So to do so, just go to the structure tab, control data, and building generation. Number of copy is 1. We want the roof level at 12 feet from plinth level. So
12 fit and just add this. Now select those beams and columns that we want to have, that we want to copy. We don't want this beam, we don't want these beams, and we don't want these beams as well. Okay, now click apply, so it will automatically create a story of 12 feet. To check the distance, just go to the query tab and query nodes. This node to this node, it is showing here distance from node 51 is 12 feet. Alright. Now we can see that there are some nodes as well on this plan. So to select this plan only, these beams in X and Y plane, there is an amazing option in MIDAS GEN. It is a selection filter. X, when we select X and select all this model, so it will select only those beams which is parallel to X-axis. Similarly, if we select Y, then it will select all the beams that is parallel to Y, and similarly for the Z. And there are options of plane as well, XY. We want only XY plane, so just select this. So only the beams that are lying on the XY plane is now being selected, but not only the beams, all the other elements that is lying on the X and Y plane is being selected. So we can see that these nodes are also lying on the XY plane, so it is selected at 2. So you want just select this thing and click on activate. Now click on this top button and these nodes have been created, so just go to select these nodes and delete. Now this node is dividing these two beams, so if we select this node and pressing delete, so it will delete this beam. So we have to merge these two beams, these two beams, these two beams, these two beams, and these beams, and this beams. When we select this beam and this beam, so it will select from this point to this point, so separately selected. Go to the Nodes and Element tab and go to the Merge Element, Frame, Selection, Remove Free Nodes, check, Apply. Similarly select this and apply. Okay. Similarly for this beam. Apply. Activate all. So this is our model. Now what we want to have a landing beam at this particular point as well. So to model that landing beam, we have to select this area, but first we have to select none at the selection filter. Select all, just activate. Okay, so there are 11 steps plus 1 landing, and each riser is of 0.5 feet, means 6 inches. So 0.5 by 12 is 6 feet. The story height is 12 feet, so just divide these two beams in the equal parts. So click on the divide element, frame, equal distance, division, number of divisions 2, merge duplicate. Okay, now create this beam by connecting these two nodes. Alright, now select activate all. Okay, now we have to tell the software that we want this particular story acting as a plinth and this particular story acting as a roof. So it is done by going structure tab, control data and story. There is nothing here in this table. Go to the auto generate story. There are the levels. At 12 feet roof, this particular point, third floor is taken level 6 feet. 6 feet is the landing level. So we don't want this landing level as a story. So just select it and click on this button to take it into the unselected list and just click OK. Now rename it as base plinth. Alright. Okay, so now we can select our model by activate by identifying the story. So if we click on the roof and click on the floor and active, only the roof story has been activated. If we select the plus above, so it will activate the story plus the columns above, but there is no columns above this story, so it is nothing shown here except this story. So below activate, so the columns that will below this story is being activated along with the roof. Similarly for the plinth, active, right? So this is the way that we can select from the story. Now all the things have been modeled. Now we will define the material and section properties. To do so, just go to the properties tab, material properties, add concrete, ASTM 4000. Okay, just copy this thing and click 3000. We want 4000 psi concrete for the columns and 3000 psi concrete for the beams. Go to the section, add, just first click on this distance unit as inches because we will define the section in inches. Just go to add, click on the solid rectangle user. Our beam has the dimensions of 24 inches by 8 inches, 8 inches by 24, 8 inches width and 24 inches depth. Line. So first we will name it as B8 by 24. Okay. So it will automatically assign to all the elements. Just click on this and copy and modify. Name it as column. All the columns are of 12 inches by 15 inches. Okay, and close. Now going to works tab. Now we want all the columns to be of 8 inches by 4. A mistake, I have not modify the name. Go to the property and 12 by 15. Okay, now we want all the columns of 12 by 15, so just go to the selection filter, beams parallel to set. In MIDAS GEN, all the lines are treated as beams. Either it is column or beam. It is treating as an element beam. Select. So all the columns have been selected now. Select this section and drag and drop. Similarly, this particular property grade C3000 is not applied to any section. So we want our beams to have this property. So just select XY and select this. Okay. So to check, just go to grade 4000 and active. Only the columns are having the property of grade 4000. Similarly, only the beams are having the property of 3000. And similarly, this is the beams, this is the columns, right? Activate all. So in this way we have modeled our building plan in MIDAS GEN. So in the next video we will apply loads and analyze it and then design it using ACI code. So see you in the next video.